The earliest mirrors were curved pieces of highly polished metal, such as brass or bronze. They're even mentioned in the Bible. Then in the 14th century, the Venetians invented very crude glass mirrors that reflected off a metallic backing. They later perfected this technique using an amalgam of tin and mercury. Eventually, the secret of mirror making spread to other cities. By 1835, a German chemist developed the silver-backed mirror that we know today. A mirror starts out as clear glass. A robot lays each panel horizontally on a conveyor belt, which transports it to the washing station. There, sprayers blast the glass with water and cerium oxide, a powder derived from a type of earth. Rotating brushes scrub and polish both the top and bottom surfaces, removing oils and other contaminants. This washing process takes about a minute per panel. Next, sprayers rinse the glass with piping hot demineralized water, demineralized because the minerals in plain tap water would damage the metals they apply next. The first metal is liquefied tin, which goes on what will be the back of the mirror. It allows the second metal, silver, to adhere because silver won't stick directly to glass. The silver is also in liquid form, mixed with a chemical activator. Within seconds of interacting with the tin, it hardens, and as it does, you begin to see a reflection. It's this silver backing that transforms clear glass into a mirror. Sprayers rinse off the excess silver, which gets recycled back into the system. The factory will seal this silver backing with 2 coats of paint. Paint by itself, however, isn't enough to protect the silver in the long term, so they first spray on a layer of copper. Sprayers rinse off the excess copper, then the panel passes through a dryer at 71 degrees Celsius. This evaporates the moisture on the surface in just 75 seconds. Now the panel passes copper side up through what's called the curtain coater, a machine that runs a continuous curtain of paint across the conveyor belt. With its fresh coat of paint, the mirror then passes through an oven heated to 99 degrees Celsius. After 1 minute and 45 seconds, the paint is cured. Now the second coat of paint. There's no reason for the different color other than to differentiate the coats. The curing period this time is twice as long and at a higher temperature, 118 degrees Celsius. After an acid wash to remove any metal residues, they stand the panel upright to inspect it. If they find a fault, such as a bubble in the glass, they cut that portion out. The factory now cuts these large panels into whatever size and shape the customer has ordered, using a special mirror cutting machine that's precision guided by computer software. It scores the mirror using a carbide wheel. Carbide is a strong metal. To make round mirrors, the machine first scores the panel into squares. Then in each square, it scores a circle. Using special tools, workers separate the squares, then the circles. To make beveled mirrors, they use what's called the shape bevel machine. First, it carves out the edge, then polishes it to a shine using concentrated cerium oxide, a stronger version of what they used earlier to clean the glass surface before plating it with metals. Mirror factories also ship whole panels to shops that do the cutting themselves. A fragile feat that's certainly not for the superstitious.